Good afternoon. This is Suraj Singh from Bharat, India. A screen share talk about some drawings, which is very important for everybody to know what is that. A screen share, almost very much important for everybody. What is a screen share? And it means I have seen one plan here. This is giving complete details of some building plan and total detailings. For example, this is here you can see certain layout plan, you can say kind of site plan. It is shown some village and road backside and side plan here. On right side name is written, and then in front there is something also here. On other side of this north line is shown, and ये ऐसा नक्शा मकान बनाने का जिसमें सारी डिटेल किस तरह की दी जाती हैं वो बताया जा रहा है. साइड प्लान, लेआउट प्लान, and this is architectural plan here. This is, you can say, architectural plan here. Plan at basement, plan at ground, plan at other levels, first floor, second floor, and other floor, roof cover. These are architectural details. And then these are structural plans here. This is structural, and say this is foundation plan, foundation. And this is column, typical column plan of that building. You can say this plan is structural one but important one. And same way, this is another level plan which is giving complete details of this building. In fact, this is, you can say, all important plans are in. All important plans are in. These plans are, of some type that you might have noticed or not noticed, I don't know. Then this is another plan of structure, another one at different levels, and also here. And you can see here, this is architectural one, same. So this is architecture of top floor. You can see this white solid here, all columns on top. Level is given, and this is stair, and various grids are there. Similarly, if you go to this one, it's here another one. This is structural. Similarly here, these columns of framing are given with beams here, all structural beams. These are all given here with ABCD grids and 1, 2, 3, 4, etc. And also here, same at different level, separate plans are here. You can see these columns here and beams, connecting beams, all here. Yes, yeah, all. And this various sizes are also given. This is another one. You can say ground structural. You see these. Similarly, at every layer, every level, every floor level, this is given. This is called detailed drawings, and sizes of beams, etc. are written here. And you can say here also structural. Similarly, this is, you can say, all same as I said. This is plan here, and this is for base foundation beams or half portion. This is, and here you see this one. This is shown differently, but this is foundation. And yeah, you can see this is plan and sections. This is same, plan. Here's having water tank here below. This is below basement. This, and here is section of this load same this way, but actually it is this way. And these are framings. I'll discuss with frames. ये फ्रेम है, फ्रेम का मतलब कॉलम बीम स्लैब, और जैसे separately I'm not showing, I'm showing you just. And also here these are, you can say, services to all these floors, just like water pump is given here, storage tank below this level, and this is the basement here. Then you go for this another ground floor services, sanitary drainage, wastewater drainage, cold water distribution, hot water distribution, storm water drainage, sanitary sewerage, like this. And this is some hot water line, here is sewer line, and this bedroom. Similarly, all services are given. This sewer line is going like this in external way. It's going like this near boundary wall, and it's going to outside government manhole. It's water meter here, and this is this way also. This is driveway, and this water is out. Storm water duct here. This is services at one floor, and also here you can see this is gully trap here, gully for kitchen. This is a rainwater outlet here, and you may say this is WC shown inside, and shower here. Same thing, WC here, and bath here. Similarly, shower here, and sink here. Say wash machine here. And if you go down every floor, same services, similar services all here for every floor. And also in different floors these are shown, these services. And if you go further, you will find same services for every floor. And here is roof water tank on terrace. This tank, actually there are more, so this water comes in, you see from below, this comes in, and then it goes from this pipe here outside here, and then it goes down to various levels after coming here. And it is a stair cover, Barsati they call it here, but this is their elevations. All elevations of this architectural plan. This is front, this is rear, this is right, and this is left. These are here 5.1 architectural section. The architectural section is here. These are sections here. These are sections A, and BB, and CC. These are sections, and you can say DD also here. So we have shown here section EE, DD, CC architectural, section BB architectural. These are here, and these are here. These are architectural sections DE, and this is the elevations. You can say elevations here. Elevation of same front, rear, side, left side. If you see this, you can see this like this from here projections, and you can see from front it's like that, and also this one is here. All elevations are shown here, so that you can see view from every direction. And this is a decorative arrangement for some floor, very complicated one. You can say internal landscape, flooring, and some designs here, floor designs. This is some garden type planter, and here is up steps going up here. This is interlocking block here, and this is interlocking block going all the way here, and this planter here, and this up steps here. Similarly, here is driveway. There is a floor. This driveway, entry gate is here, and this fountains in this planter, and this is a different height of decoration. You can see this is landscape internal, and this as I said, site location plan, and this is your different structures. Now in this, actually, why I'm showing you all this, I'm just trying to show that these are minimum you can say minimum level requirement for whatever work you do, architectural, structural, services, and whatever is there is to be done. Otherwise you cannot say these are minimum. There will be many more after this. Before this, it was conducted, soil investigation was conducted, what sort of soil there is, and it was clay. In this case, clay was, you see this is foundation here. You can see this is foundation here, foundation beam and small spread here, and this is soil improvement. You can see if I blow up this, you can see this portion is beam and this portion is soil improvement. We removed soil from here and put granular material here, 40 mm material, and fill with that 20 mm, and then dust in that and compacted. And this is RCC foundation, which is spread all over. This is spread all over. If I see foundation plan, you can see that this is basement. I'll see foundation plan so that you will be clear about what I'm talking here. This is plan, columns, foundation beams. These are beams which I showed here. These are everywhere, and this is improvement here, as I said, in soil improvement, foundation beams, and these beams go all over there. It goes here, it goes all over there. Continuation, no break, no other foundation, continuous beam, continuous, and also on this column start from beams itself, no foundation separate for columns, foundation, all these beams. This is what this design is, and everywhere this is, you can say, frame hull portion, same thing, and different areas. This is hull portion here, so it's the same status and same thing here. This design is to be shown to people that do not take it very lightly. These columns cannot be inserted according to your choice. कॉलम्स को हम कहीं भी चाहे नहीं लगा सकते, ऐसा है, हम जहाँ दिल आए लगा देंगे, ऐसा नहीं। जहाँ इसकी ज़रूरत है वहाँ ही लगता है, आपके कहने से नहीं लगेगा। जहाँ इसकी टेक्निकल रिक्वायरमेंट होगी वहाँ ही लगेगा। आप कुछ भी कहते रहें, आपकी वास्तु कुछ भी कहते रहें, लेकिन जहाँ ज़रूरत होगी वहीं ये लगेगा। आपके या मेरे घर के कहने से नहीं लगेगा। इसमें लोड कहाँ आता है वो देखना पड़ता है। जैसे कि लोड यहाँ आया, ये देखिए, यहाँ हम ऐसे लोड को एंगल पे लेते हैं, इससे एंगल लेते हैं, दिस इज एंगल वी टेक लाइक दिस एंड वी टेक एंगल लाइक दिस एट 45 डिग्री। आप इमेजिन कीजिए, देयर इज़ अ लाइन हेयर एंड लाइन हेयर, देयर इज़ अ लाइन हेयर एंड लाइन हेयर, एंड दिस इज अ डिविजन लाइन हेयर। This is one area, this is another area, this is another area, and this is 4 areas are here. So this portion, this one, this trapezium load shall go into this portion, this trapezium portion shall go into this beam, this load shall go to this, and this load shall go to this, and similarly every portion is divided like whatever it is, and that load goes there accordingly. This is the basic principle, and if you don't follow, your slab shall be out of load, unbalanced load. There is no balance. These columns purpose is, this beams purpose is to balance your loading system, just like in electrical you do balance of electrical loads, and you provide distribution boards for that purpose. You don't take one board and say I use this distribution board for all loads. That's not possible. It can result into fire. आग लग सकती है उससे अगर आप ओवरलोड कर देंगे। इसीलिए यहाँ पर भी हम कॉलम जो लगाते हैं, जो बीम लगाते हैं, उसका पर्पस यही होता है कि हम लोड को हर फ्लोर पे बराबर डिस्ट्रीब्यूट करें। बीम पहले बीम ले, उसके बाद कॉलम ले, और फिर नीचे पहुँचाएँ। और वो खाली लोड नहीं, उसका मूवमेंट भी होता है। वी हैव टू टेक इनटू कंसिडरेशन बेंडिंग मूवमेंट, शेयर फोर्स, डिफ्लेक्शन, ऑल दैट। है डिफरेंट टर्म्स हैं ये। जैसे ये कोई जैसे बीम लोड आता है, झुकेगी, आप किसी चीज़ पे खड़े हो जाएं, स्टूल हो या कोई वीक चीज़ हो, और आप देखेंगे वो नीचे झुकने की कोशिश करेगा, उसको हम डिफ्लेक्शन बोलते हैं, नीचे जाने के लिए। उस डिफ्लेक्शन को रोकने के लिए कैलकुलेट करते हैं कि कितना आएगा नीचे, उसको कैसे रोकेंगे। ऐसे ही ये लोड स्लैब पे कितना आ रहा है, ये कितना नीचे जाएगी, उसको कैसे, हाउ टू स्टॉप दैट sagging, नीचे जाने को sagging कहते हैं. How to stop that sagging, how to control that, that is important. And then we take these two columns. ये सब सिंपल चीज़ें नहीं हैं, बट इंफॉर्मेशन के लिए आई एम जस्ट टेलिंग यू, इंजीनियर्स नो ऑल दिस. It is important that public should know something about that, because हमें 10 लगाने हैं, हमें 12 लगाने हैं, ऐसा नहीं. जहाँ आएगा वहाँ लगेगा. Wherever it is, it comes from calculations, it comes from geometry of your plan of your building, it will be there. अब देखिए I used here, अब देखिए मैं आपको दिखाता हूँ एक प्लान में, यहाँ है ना. अब इसमें मैंने जो दिखाया है, आई शो यू दैट वन, दैट्स वेरी इंपॉर्टेंट जस्ट फॉर अंडरस्टैंडिंग. दिस इज हेयर, लेट अस से दिस इज स्ट्रक्चरल फ्रेमिंग. यहाँ अब देखिए ये दिस इज प्लान ऑफ बेस बीम्स फ्रेमिंग हॉल पोर्शन. इसमें एक दिस इज स्मॉलर, दिस इज बिगर, दिस इज ऑल्सो बिगर, एंड दिस इज ऑल्सो लाइक दिस. भी हमें यहाँ कॉलम नहीं, लेकिन बैलेंस करने के लिए हमने बीम डाला है इसमें, ताकि लोड को बैलेंस हो जाए. इधर कॉलम है, इधर कॉलम है, यहाँ देयर इज़ नो कॉलम हियर, देयर इज़ नो कॉलम हियर. दिस कॉलम एंड दिस कॉलम आर अबाउट 37 or 36 feet or 11 to 12 meters. This here you can see this, but here is column, here is column. This is less, this is very long, and this is, you know, because it is hall, we wanted this portion to be full height, treble height. This is too height, you know, 7 meters or 6 meters height. इसमें यहाँ column नहीं चाहिए. अगर if we fix column here, then this can't be hall, this will be like room. So we just did not put any column. We considered load to come here and here and here and here. So this is half load is going there, half load is coming this side, and here is distributional load, as I said. And this triangle here and this triangle here, this load comes in. Yes, this is technique, load distribution on slab. There are two types, one-way slab and two-way slab. When it's too long and width is less, it's called one-way, means load goes this way and this way. Here it's two-way, load has to go on all 4 beams. That's difference here. That's what I'm saying. It's not in my choice or your choice or some pundit's choice or some other body choice that you have to use female columns and that columns. I just watched, saw that you know, people talk like nonsense, this nonsense. तो हमें इतने कॉलम लगाने हैं, हमें स्टेप लगाने, ऐसा नहीं होता. Now similarly, if you talk of stairs, same thing. I'll show you now what actually that is. Now say that stair here, you can see this is stairs. This is you know, difference of here no basement area, this one, and this one is basement area, hall area. So there's a difference of, you can say, 2.5 feet or 45. You know, we have provided some steps here to come here, and this up goes here. As you can see, we have used 5 inches or 125 mm riser. You know, vertical portion of steps is called riser, and horizontal portion is called tread, T-R-E-A-D. Riser बराबर साइज के होने चाहिए, equal. All risers must be equal height, and all treads must be equal height. Landing is different. This is important. You have to select height of floor depending on riser. Don't take direct height. Oh, I have to take so many meters. Then your riser will be in decimals, and that's no good. So either fix, we say 150 mm or 125 mm or 100 mm. In public buildings, it's 100 mm. They don't want people to use 150 mm or 200 mm because it's public place. In private, it is 125 mm. It can be 150 mm. It's not time that you have to take 200 mm. You're tired in that. So what I mean to say, stair is very difficult to design, because stairs slab is inclined like it is everywhere. It's inclined. If I have a section, I will show you some section of stair here. I think it should be somewhere in structural. Yes, it is in structural here. You can see this step, you can see here, and you see it starts from here, goes up, then goes this way, goes up, and like this it is continuous without break everywhere. It should be like that. No way, there is no other way. And these are steps in different areas, different ways. So I mean, we have to design a stair which is very difficult from building viewpoint, because I have seen people are using different sizes of risers in same stair flight. That's not correct. People, when you rise on a stair, when you ascend means go up stairs, and we come down, it's called descend. When you use ascending of stair, you go upstairs, means your leg automatically programs height of stair. And if there's some difference, if you won't care, but you may fall, you may stumble. This happens, means you cannot be attentive to all waist, all stairs, all steps, all time. Maybe first time you are careful, and second time you may not be. It's everywhere, means how many times I have gone to this. You remember people fall on steps. You remember it happened when our PM fell in the, I think, Haridwar or somewhere. He was walking on some, he fell, and there was reason, because top riser was unequal. This happens, and this stair must be very, monolithic. It's not that we cast waste today. Waste means this portion, I can tell. This portion, this is called, I will show you. This portion of one, this from, you see, this slab is called waste slab. These are steps on this. This combination of steps and this slab is called flight. We say it's flight of stair. These steps must be having reinforcement, and this stair must be having reinforcement together, and these should be cast same time. What I see, people cast this and they forget this, they cast this later on. This is mason's technology, which is incorrect. This is not, concrete should be monolithic, or some people cast this in you can say concrete and put bricks here. That's completely wrong. This is a stair, and generally I am showing you this design is like this, from center of this landing to center of this column. We consider this span for loading on the stairs. It doesn't come here, it comes from here. Let's this way here. Let's say this is a stair, this is landing, this is half here, this half, and this column, this beam or column, this is considered horizontally. I'm not saying inclined. Horizontally, this is considered its span or its load catchment. We have to calculate this from here to here, considering this as center point and this as center point, and we see how this load can be distributed on this landing and this landing. That's the way of this. And similarly for all this. And old style reinforcement is they triangle, sometimes box cut down, they like. Now better take both up and down all steel and make it like a beam, so that it doesn't fail. And similarly make it like a beam, make this waist like a beam, and provide steel in these steps also, so that your stair is monolithic with framing. This is basic understanding how you can do. And also I have shown these frames. You should know what I'm talking of. I'm talking of frames. This one was foundation. When I say, this is story 1, story, this is story, like this is story. So there is column that is coming from footing here. This is foundation. From here columns rising and beams are here, then columns rising and beams are here, like this. This complete beam, frame and columns connection, column and beam combination, with slabs is generally called framing. We call framework means beams and columns, because beams are already connected to slabs. So this is 3D frame, we call it in this direction and in other direction. This is Y and this is X, or you can say this is Z, X, Y, and then we can say other direction is Z direction. According to software, I'm not using software, I'm just trying to explain how we do. And labels and rings, all details we have to do. For example, I have shown here it is say hall roof. I'm saying 60, this is then beam depth, 60, 600 mm, you can say 2 feet, 600 mm is depth of beam, and here is column, and you can say it is 200 into 300 mm. This is 200 mm. This is a beam which is to be made cast monolithic with slab, and this is column here. This column is 400 by 1000, because here length of span is more. So I have taken 400 wide column into 1 meter length, and then in this beam 12 to 12 top and bottom, 12 steel, T12 is written, and 8 rings, 8 mm dia, 100 spacing, something like that. So 200 spacing here, and this rings one, this is beam column size 400, 600, depending on which column is that. And we show like example, beam is here, this is beam here, and this is beam here, and we show dimensioning of this stair, how many meters from here this landing starts. Similarly, what is from here, you can see, to this, what's length of this shuttering, so that carpenter can fix shuttering here, and what's from column to this size is, so that it would be easy for carpenter or formwork to fix it. The carpenter need not use that judgment, his own judgment. We give him dimension, like we start here. This is formwork, but formwork is here, but that formwork is another one. This is this side and that is that side. So all dimensions are given like this. Here from here, that shuttering, this is also shuttering. Straight away, that carpenter would cut accordingly and fix. This is called a kind of working drawing where work is to be done and levels are given. For example, in minus, when we say it goes below ground level or whatever level we fix, and we say plus, say here is 0, then minus 1.25 means we are going down. I have taken this from basement, and then you say it's going down further there 2.25, and like that. So it means it's indicative only, and we go 3.25, 6.25, 9.25, and 11.05, and I say riser is 125 mm, tread is 250 mm, and this is grid 3 frame, like that is grid 5 frame, like that is grid 4 frame, like the grid 2 frame, grid 1 frame, 1, 2, 4, like that, 3, 5. These are framings. Which are, these frames are these. If I can show you column typical, I show column typical 600, 400, 1400, and let me show you where I put grading. Maybe here, I don't exactly remember, this was done in 2008. You can say this is one frame, this is another frame, this is another frame, this is another frame, this is another frame, and yes, it says frame 5, frame 4, frame 3, frame 2, frame 1. Otherwise, I have not taken this side because this space is very limited. This is main frame. Others we taken because this is not very. So we took, by what load can we take beams here. So this is, you can say, taken by using, planar, one plan framing, and it goes to foundations in such a way. And also we can say this, because this formation level was clay based, clay soil, up to here I can say 20 feet or 6 to 7 meter down, it was clay. So I did not trust clay. So I removed 300, this 300 here, 300 1 feet approximately. This portion of clay was removed, otherwise I will start foundation here itself. No, I said no, I don't trust this clay. I removed clay throughout this. I mean to say throughout here. Complete plan, if you see plan of this, complete plan, I removed that one. I don't know, I have some excavation plan also. Where is that? I exactly don't remember. Where is that? Maybe in some other drawing, not exactly herein. Well, I prepared an excavation plan like this, completely like this, excavate whole area, let excavation will go down, because I have to create foundation like this. This is continuous. This foundation beam. It says it looks like T, but it's not T beam. This is main beam, and this acts as spreader of load. And main bars are not vertical. That's for column only. For beams, horizontal bars are there. A reinforcement, I've not shown this, but it says B1, B2, B3, etc. All beam. This is foundation beam. This is 400 wide. This is, you can say, if you say currently this is 20, and this is 1 meter here. So this is 1 meter 20 beam, or you can say 1 meter beam, 120 like this, and 20 extension projection here and 20 projection here. So this is like this. This is only for purpose of spreading load. This is main beam that takes load and transfers to soil, to first of all to this improved layer, and then to soil. That's purpose of this continuous beam. This is different method. This is not a straight beam. I don't call it a straight beam, but a kind of that, rather than taking complete raft, I try to continuously, so it acts like a stool. You have seen a stool in your homes, or table in your homes. If you stand on stool, you won't fall until you stand at corner of stool. And this is same thing, means I calculated moments for this, and I found center of gravity of loads and center of gravity of building, and in plan where is equal, I find x-axis, and then I found another axis where load line is. So similarly, I checked all that, how much out of line this load goes, because this is not symmetric, this is unsymmetric. Certainly there will be some out of line action. That was considered, and I took conservatively a seismic moment, you can say 25% of vertical load, and then applied them accordingly. So there are so many, you can say, considerations in buildings. You can say everywhere it's like that. These still I'm not done on this rebar drawings, but that's required as well. So just for your information, I'm saying what sort of drawings we have to build: architectural, structural, services, and many more. And these are for purpose. So you see, this takes time. This is not 1 hour or 2 hour job. You have to think and then check many times, edit many times. That's only way that you can do something, or otherwise you waste your time, you waste others' time. So in this building, I have another page, but I cannot continue in this because of FB's restrictions, that one page only can be taken into screen share, and you cannot extend it to another page, otherwise you have to make another video of that. So in this was, you can say, excavation, soil investigation, then you start this, and after building permit, etc., then you can say soil improvement, and then you can start foundations. So we use ply and timber for that. We did not use your standard columns of contractors. These columns are 40 by 60. You can see here this column is 40 by 60, or you can say 400 by 600 mm, because this is quite more than 6 meters span. The same thing is here, 400 by 600, 400 by 600. Comfortably, we have to keep in mind that fire is to be kept into consideration. In case of fire break, first of all, I provided fire tank or common fire and use portable water tank. That's one part. But there's another part. Suppose your building gets fire, what solution is there? At least 1/4 of this column, or 1/4 to 1/3 of this column, external surfaces shall catch fire first. This is very common. Not only this column, also these beams, 3 sides shall get fire, 2 vertical and 1 soffit. This would be subject to fire. Similarly, if I take this, same thing happens to this. All these 4 sides will be exposed to fire immediately, and 3 sides of this slab is also subject to fire, but direct fire impacts these structures. These are beams and columns which are responsible for load and bending moment transfer. So what happens in half an hour, you can say in half an hour, 20 minutes, this portion shall be weakened by thermal impact. Thermal resistance, there's no major thermal resistance in concrete. It cannot withstand much more temperature. So also steel is there. If cover is there, say 340 mm or 30 mm, let us say 40 mm, then that 40 mm heat can move into this 40 mm maybe in 15 minutes, 20 minutes, because temperature of fire is too high, and it after it goes it can impact your steel, and if your steel is old and rusted, it is then very easy for fire to can say damage that portion of reinforcement rings and then main vertical columns. So this portion, you can see, if you take a curve like this all around here, this portion shall getting gradually, you can say, thermally impacted, and it moves internally like this, and like this. First will be exposed surface line. This portion of peripheral curve shall become no use during fire until fire tenders arrive, and only internal elliptical portion approximately shall be strong enough, maybe in 1 hour or when fire brigades come, or otherwise all will become useless. But let us say 1/3 of this is damaged during fire. So in actual sense, we get a reduced section here for every column and for every beam. Beam also, as I said, let us say beam is there. If beam is there, let us say this is a beam. Fire applies here. This is cantilever here. Let's go outside. This is a beam. Fire happens. Now fire applies here. Fire applies here, and fire applies here. Up to here at least, maybe more, maybe about no. But this fire will damage these three sides. So you can say this kind of external impacted section shall be weakened, and your stresses in all materials shall be limited. Here this will be at least working for some time. So that's the purpose of keeping some more section of cross sections of beams, columns. Generally there's a tendency that beams should be, they are even the good section, and column should be stronger than beam. And slab is an element that we consider separate, because slab's load is calculated independently and these loads are transferred to beams. But slab is also monolithic with beams and columns. Practically beams and slabs, which you call linter, beams and slabs are cast monolithic, and also small portion here, which you can say sometimes they cast columns up to here, and this portion is left. This portion is, they call it neck actually. This portion and this beam portion and this slab portion, wherever it is, or here, these are cast monolithic. Columns are cast separately because it's not convenient to cast whole columns. So columns cast up to here or somewhere, and then we prepared for construction joint, and these are here they're collapsed at neck, and then that shooting continues with this beams, and that way we work. This is practical way. Same happens, and some people say we cast 1 meter column first or 2 meter, then that is not preferable. It's better to cast this column if you have complete technology how to pour it. If you can say your pump is here, pump means concrete pump I'm talking, you use a column here, pump boom, this pipe boom comes in down this pipe of mobile pump or whatever pump you have, that comes down, and if your pump pipe boom goes up to here, let us say up to here, and this is a 1.5 meter height, this portion. So your pipe is authorized to drop concrete from a height of 1.5 meter. This is acceptable because this height does not segregate, does not separate your stone aggregate and your sand. Concrete remains, what you mix, grain mix, it doesn't break during pouring. And if you fall from here, you drop from here, it will break. Mean mixing got no meaning in that case. So it's better we go down, start from here, go up, let us say 40 centimeter we cast, and we fill that 40 centimeters and provide vibrator here, then take out vibrator and bring again maybe after half an hour, after pouring same 40 centimeter or 400 mm in all columns, how many you have already, then another 400 like that, applying vibrator, and this vibrator nozzle must go down into previous layer also for purpose of interlocking both layers. and like that it moves until you reach 4 meters here. So that's called one stage pouring. We call it one stage pouring, which is professional pouring. We don't take 4 times, or we use shutter here, full height shutter of column. That is real technology. Means we have good ply, 18 mm ply, and you have 2 into 3 inches or 75 into 50 mm or more, and then you have tie bolts in this, and ties and clamps like that, and then supports. I have shown all these details in separate talks. I think if you have seen that, fine. Otherwise, I'm just telling you. And beams cannot be cast separately. Beams are to be cast with slab, and that's framing we do. And this slab of stair is also can be cast. What actually is done. First flight and this landing are cast in one go. Generally, then this is not necessary, but generally these are cast in one go with steps. Of course, don't forget the steps. The steps is very important part. And when we cast this portion, it is cast with upper slab, and this is cast after slab is done. So this is cast one landing, and this is cast in upper one. This is general practice, but nobody stops you if you take whole slab of stair, this one or other one, whatever you have, like this. If you take whole this and that together, no bar. If you take separately, no harm. Nobody wants this. You have to, dowels you have to leave here. Similarly, dowel means extension of bars which are not concreted but they are embedded in this landing and beam. These go up, you prepare, and then you pour complete like this. Remember, it's monolithic connection. It is not separate connection. And if you take 2 flights, then you cast here, then prepare for construction joint, prepare well, and then cast this one. This is generally done like that. And purpose of this was to show you triangles. I don't know why I'm explaining what you should do. It's because of, I think, mind says no, speak this also. I'm speaking. Well, this was purpose of trying to go into prosecution. I don't know why. Well, anyway, it happens. When you talk, you don't think what you're talking. Just keep talking and explaining what's required, what's not required. And so I say, this is actually what we do in field. And I think you understand. जो मैं समझा रहा हूँ कोई बहुत अजीब बात नहीं समझा रहा हूँ. मैं सिर्फ इतना कह रहा हूँ कि बहम में नहीं रहना है हमको. जब कोई मकान का ड्राइंग बनाना है तो टेक्निकली और एनालिसिस करके दिमाग से बनाना है. भूत प्रेत समझ के नहीं बनाना है, या क्या वास्तु कहेगी, या क्या हमारा पंडित कहेगा, या कोई क्या कहेगा. ये फालतू की बातें दिमाग में नहीं रखनी है. पूजा पाठ से मकान नहीं बनते हैं. मकान सोचने से बनता है, और एनालिसिस से लोड कैसे कहाँ डालें उससे बनता है. ऐसे ही बन जाते तो फिर सबके मकान ऐसे ही बन जाते. अरे भाई, जो सोच रहा है आपके मकान के लिए वो इंजीनियर है या जो भी है, अनपढ़ तो नहीं है. उस पंडित से तो काफ़ी ज़्यादा पढ़ा लिखा है. वो पंडित क्या बताएगा, ये वो डायरेक्शन है, ये डायरेक्शन है. आपको खामा कोई इसमें तत्व नहीं होता है, कोई सब्सटेंस नहीं होता है. बस मूर्ख बनाता है और हम लोग बन जाते हैं. मेरे अपने घर वाले बन जाते हैं. लड़ाई होती है मेरी फिर से. क्या बकवास करें, क्या न एक्सकेवेशन कराई फालतू में. ज़रूरत नहीं थी यहाँ पे. यहाँ कालू मारा है तो वहाँ कहाँ समझने वाला है. आप ये बना रहे हैं जीना, तो जीना का मतलब है स्टेयरकेस. इसमें हमें इतने रखने हैं कि जो 2 से भाग हो जाए. अब भैम का क्या इलाज है बताइए आप, क्या इलाज है भैम का. अब मैंने अपने मकान में लगाया एक फ्लोर में 26 स्टेप्स राइजर्स लगाए. 13 राइजर एक फ्लाइट में 13. अब लड़ाई है, हम तो इतने लगाएंगे, इतने नहीं 12 लगाओ. अरे भाई, ऐसे नहीं हो रहा है. नहीं समझते. लेकिन उनके समझने या ना समझने से क्या होता है. जो कैलकुलेशन है वो है. कैलकुलेशन बड़ी है या आपका बहम. सोच लीजिए. बहम का तो इलाज हो नहीं सकता, लेकिन कैलकुलेशन तो जवाब दे सकती है. मेरा कहने का मतलब है, बेकार की बातों में ना घुसें. जो दिमाग कहता है काम वो करना चाहिए. मन तो छलावा है. मन का क्या है, मन तो पता नहीं क्या क्या सोचता है. वेल, मेरे को आपको जो बात समझानी थी इसके बारे में, ये पर्पस ये था. ये बहुत पुरानी ड्राइंग मैंने दिखाई है आपको 2008 की, जब मैं अपने मकान का नक्शा बना रहा था, उन दिनों की बात है। तो इसमें कहा, आप खुद देख लीजिए कितने ड्राइंग ऐसे गिन लीजिए आप, देखिए 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39, अबाउट 35-40 ड्राइंग 30 लगा लीजिए आप इस छोटे से मकान में है। और ये अगर बड़ा होगा, ज़्यादा होंगे मकान, तो कितनी ड्राइंग होंगी ये सोच। इसमें तो अभी पूरी डिटेल भी नहीं है, ओनली आर्किटेक्चरल एंड स्ट्रक्चरल। अभी तो उसमें सरिये का नक्शा नहीं है, इसमें बहुत सारे नक्शे दूसरे नहीं हैं। मतलब 50 60 70 ड्राइंग अगर हो जाए, और बाद में छोटे छोटे स्केच भी होते हैं, स्टैंडर्ड स्केच, यहाँ पे ऐसे बनाना है, वहाँ ऐसे बनाना है, यहाँ फ्लोर के अलग अलग लेवल्स आ गए, यहाँ ऐसे करना है, वो सब इसमें नहीं है। और फिर ये कैसे करना है वो लिखा जाता है, जो कैसे करना है। खैर हमने नहीं लिखा क्योंकि हमें ज़रूरत नहीं थी, हम खुद कर रहे थे। तो लेकिन आप अगर किसी को देंगे तो उसको हम बोलते हैं स्पेसिफिकेशन। खुदाई एक्सकेवेशन कैसे करनी है, उसके ऊपर चिनाई कैसे करनी है, ब्लाइंडिंग पाउडर कैसे डालनी है, वाटर प्रूफिंग कैसे करनी है, फाउंडेशन कैसे बनानी है, इस तरह ऊपर कैसा करना है, ग्राउंड फ्लोर कैसा करना है, फाउंडेशन की बैकफिल कैसे करनी, ये सब बातें लिखी जाती हैं। मजाक नहीं है कि मेरा जैसा मनाया कर दूंगा या मैं उसको बोल आऊँगा साइड पे जाके वो कर देगा। नो, इट्स नॉट लाइक दैट। You have to write everything according to contract, and you must give every in details. We want this. If you have some question, you can ask this, or you give your method. We have to write method statement for this. We have to specify for this. Method statement are written at time we are doing job. At that time, we have to write what we have to do. It should be completely clear. It doesn't matter who write this. It doesn't matter you are architect, engineer, or whatever you are. You are a person responsible for construction of this structure. It's your duty to tell those persons who are busy on this, they should know what they have to do. Otherwise, carpenter will do its way, and steel fixer will do its way, and mason will do its way, and you will not like to. You will fight with it. You will know, don't be that. Some people know you go to site and tell them, no, it's not so. You have to write everything, what is to be done, so the supervisor on site can read that, engineer of site on site can read that, can understand, implement that. And if it's not implemented, that person is competent to be on site. That's why I say, means you have to understand this. It's like treatment, it's like management of engineering, just like medical management. Then you just write some medicine. No, it's not there. You have to give complete. These are x-rays of what we say. What we propose is this, these drawings. That was my purpose of explaining to you. And it's not that this I have explained to you. I have only explained to you very little what is done. There are many much more than. Then we have to measure this on site actually, how to measure, how to check what work has been done. That's not, I have told you, we have to check everything on site. We have to check excavation, setting out, and then we have to check excavation levels, and then there's a compaction is very important. As I said, compaction means pack as much as possible, increase unit density of your fill or site soil improvement. You have to make it as much as air out if possible, and water out if possible, as much as you can expel out of your fill. It's better, because compaction is immediate action on soil or backfill or whatever you compact. We test that and we see what is density. We achieve field density, field dry density, that is ensured that it is within limits of what sample is submitted and what results of that sample are, and that's called proctor density. And that proctor density must be 98% for structural backfill, for structural basis. It can be 95% for below ground, below floors you can say, and it can be maybe 92 or 90% for general areas where there's no load, or you can say some landscapes like that. So there are various ways to do it, and it's not that density. Then we have to see, when we backfill, we have to backfill in layers of 150 mm backfilled or thick, final one from 200 mm, and that's also tested. People don't do it, I know, they don't want to do it. They just fill everything by excavator, put water on that. They think it will be done automatically, but nothing is automatic in this world. Similarly, we have to check layouts of foundations. We have to apply and check steel how it is well. Then we have to provide concrete covers also, spacers we call them. Either is to precast house site or you buy it. Well, I think precasting is best one for precasting site. That's a professional one. And if it's binding wire, that's so that it's concrete goes into concrete. You can say family member goes into family member, and concrete is family, and that mortar it may be, or it may be small very small dust in that can also become same family. It goes there. These are much stronger than plastic when you use, and plastic is not very good, So foundations we do like that, shutting of foundations, and we do reinforcement like this, and then we clean everything by, and then we pour it using, you can say, not more than 40 centimeter of 400 mm one go, and we vibrate that, and then we start work of columns and then other work, and we check setting outs, we check dimension, we check plumb line, and we check this exactly in same setting out line. Plumb is checked on at least two sides, and dimension are all four dimensions are checked, so these columns remain in line, and also these columns remain vertical, true vertical, and likewise we check all systems of, when we apply, we prepare for supporting system for slab. People do like bullies, or they do like something. Nobody works for except 2 or 3% of buildings I've seen where system is used. That system is real one. That's very strong system, because your weight, your load, setting load, material load, all work, and this unbalanced load during pouring, because one side people are standing, other side pouring is going on. So there is no unequal load. There's unequal load, and there can be eccentric loading. Sometimes there can be accidents, and this happens. We say, oh, see, slab is coming. Actually, it's shutter that comes out, system fails, and that's the cause of problem. So we have a system that be very strong. That means that can take all vertical loads and have really braced horizontal bracing and diagonal bracing, and then it can absorb movements, it can take everything, and that doesn't fall in that system. This cup log system is very important, because cup log, this is standard grid system. That's 1.25 to 2.5 meter size of pipes. These are fixed horizontally, vertically, and means we have to see professionally. It doesn't cost much, but safety is most important. If safety is not important, safety and quality are more important in everything like that. Now with this I close this video share, or you can see this document share. I hope you like this. This is for your purpose. It's not, I'm not using very much technical terms, common term. I'm using very common term for people to understand that. I hope you find this. If something I forget, I don't remember now, means whatever information thought I intended you know that. So I think know that, and some knowledge you might have got. Important thing is concrete quality is very important. That's missed everywhere. People don't understand quality, and those promoters or builders or engineers on site, others, they are ignorant about qualities. They don't know what concrete quality is. It should be, and that's unfortunate part, that we are very highly qualified engineers in our country. Some are BE, some are ME, some are PhD, but quality is still in ditch. It is in KC. You can say quality of concrete is in kindergarten. I cannot say in primary school even. Unfortunately, I don't know what's ignorance there, what's carelessness there. Maybe some people take care of that. I can't blame all, but generally, which is visible, which I can see from here all over this, means quality is considered very bad, and quality is very bad, means product is very bad. It's not functional. So it is. I hope I cannot talk about quality here in this with this some other scope of this time. I'll include this video in main video of management, as you do routinely do. Thank you very much. I stop.